Hey folks, welcome to my channel number 10. We have the problem on our screen. Find the derivatives of the following function using first principle, right? So in this video and in the subsequent videos, we're going to look at problems on derivatives and differentiability of functions. So what do we mean by derivative? Derivative is nothing but my d by dx, right? And how do we represent it? Whenever we've been asked to find a derivative, all that we've been asked to find is my dy dx, right? And what is my y? My y is nothing but my f of x, right? And how is this usually represented, right? While we will look at examples on examining the differentiability of functions, I'm going to write how is derivative actually represented using first principles, right? So if I'm going to treat my f of x equals y, right? And my dy by dx is written like this, right? My f of x plus h minus f of x and the whole divided by h, right? And h is something very familiar to us where h is infinitesimal value which is tending to 0, right? So this is how we represent dy dx, right? So limit h tending to 0, f of x plus h minus f of x divided by h, right? And similar to the concept of left hand limits and right hand limits we saw in continuity of functions, we also have left hand derivative and right hand derivative of functions, right? So when I have my d by dx as limit h tending to 0, f of x plus h minus f of x divided by h, we call it as the right hand derivative because we are calculating the derivative at a particular point, say x naught, and x naught plus h, which means that uh, we are on the right hand side of x naught, right? And x naught plus h minus f of x naught divided by h as h tends to 0 is called as your right hand derivative. And similarly we have our left hand derivative h tending to 0, but this time we are on the left side of x, and therefore my denominator takes a value minus h, right? So graphically, what does this actually mean? D by dx is nothing but the slope of the curve y equals f of x, or it could be slope of the curve or the line or whatever be f of x at a particular point x equals x naught, right? And so that's what we mean by d by dx, right? And I've also done a video in the past where I have shown graphically how d by dx is nothing but the slope of the tangent to the curve f of x at a particular point x equals x naught, right? And I request you to take a look at that particular video as well, and I'll put a link to that particular video in the description when I publish this video, right? So this is what we mean by d by dx. And so derivative of a first principle expects you to know the basics of limits and continuity, and we have done enough and more problems on that particular topic. So I think we can straight away get to work. Now for all these problems, we're not going to work out both the right hand and the left hand derivative. The assumption in this particular problem is the right hand and the left hand derivative exist and are equal. And if they do not exist, we'll figure out that using the first principle as to why they do not exist, right? So let me directly get to work here. I'm going to pull out what I have for my right hand derivative, and I'm just going to write it as it is, and let's see what do we get, right? So my limit h tending to 0, and I have my f of x plus h. And what do we mean by f of x plus h? All that I need to do is pull out my f of x and replace my x by x plus h, right? Plus 7 minus of my f of x is again minus 4x plus 7, right? So I have written my numerator, and what is my denominator? Divided by h, right? And when I rewrite this, I can see that I have minus 4x minus 4h plus 7 plus 4x minus 7, right? So my 4x and 4x gets cancelled out, and I'm left with my 7 and 7 also gets cancelled out. So I can pull out my pencil, and my 4x and 4x and my 7 and 7 gets cancelled. So I'm left with minus 4h in the numerator, and I'm left with a h in the denominator, right? And as h tends to 0, I do not have to worry about my h anymore, because again it gets cancelled out, and I can comfortably say that my d by dx is minus 4, right? So that's how you establish the derivative of a function using first principle, right? And in case you want to check by working out the left hand derivative, let's do that as well, because this is the first problem we are doing on derivatives. So let's write it out. My dy by dx is nothing but limit h tending to 0 f of x minus h minus x divided by minus h, right? So let me write down my f of x minus h, and my x minus h is minus 4 into x minus h plus 7 minus of minus 4x plus 7, right? And all that we're doing is wherever we have an x, we are replacing it by an x minus h, right? And remember not to forget this minus h, right? I'm very particular about the minus sign here. My numerator becomes minus 4x plus 4h plus 7, and have my plus 4x minus 7, right? And I still have my minus h in the bottom. So that allows me to cancel out my 4x and my 7 as well. My minus h, which is nothing but my h and h gets cancelled, and I'm left with minus 4, right? So in this case, we notice that my right hand derivative and my left hand derivative do exist. They are finite and they are equal, right? So there are three conditions when you examine the differentiability of a function. One is my dy dx, be it my left hand derivative or the right hand derivative, both of them are finite and they exist. That's condition one. And condition two is they are equal, right? And that's how we establish the derivative of a function using first principle, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.